is my division circuit. It is, I believe, complete now. I don't have it hooked up to inputs. It's just a bunch of subtractors. You got 9 layers of subtraction outputs sent along the bottom, little circuits on the top to tell you whether or not the result is going to be negative, just so it speeds up the process a little bit faster. I'm really tired right now. It's the middle of the night. I just finished this, but let's throw a couple numbers in there because I already have them loaded. So we are gonna do the denominator input over here, or the dividend I should say, is 145, and the divisor is 26 times set midnight. Let's hit the go button. So the first thing it's gonna do is start pulling the inputs up 1 digit at a time from that side, and then start loading them until it matches the length of the divisor, and then it stops loading and does the first subtraction. The first subtraction won't work because you have the first 2 digits of 145 is 14 minus 26. 26 doesn't go into 14, so we're going to get 0 out, and then it's going to pull in the next digit as soon as that little line reaches there. And you can see the output indexing over here. So now we have 145 divided by 26 loaded. 26 goes into 145 5 times, with a remainder of 150, or sorry, 150 after you carry the 0. So once that reaches, you'll see our output of 5 over here to the left of the decimal point, which is the gold. So there you go. And the full result of this calculation will be 5.57692. I checked with my calculator. You can see that the 5th line in the subtraction thing here is lit up. So 26 goes into 155 times, so the remainder of 20, carry the 0 is 200. That's 200. I can show you if I look over here. 200. 26 goes into 207 times with a remainder of 18. So we'll see 7 pop up here. Right there is 7. Remainder 18. 1, 8. Unfortunately, I could make it faster if I varied the time of this clock with the length or with the number of subtractions that are available, but I haven't done that. Alright, so 26 goes into 180 6 times. We got 6 there with a remainder of 24. 2, 4, 2, 4. So she is chugging along. Basically, the reason this line is so long is because it has to have enough time for the furthest back one to read. If it only has time for the third one to read, then anything longer than that won't read, and it'll get stuck. So it has to be really, really slow. Oh, it stopped the it stopped the subtraction early because I took this value from where I should not have. Okay, so you're gonna see a quick fix here on camera. Oh, for crying out loud. That's gonna interfere with that. There, I know what to do. There we go. Problem solved. Now I can make it do the last one right here manually, which is 2. That was 240 divided by 26, 9 with the remainder of 60. 60 goes into 20, or 26 goes into 62 times. So there you go. Time set noon. All I have to do now is hook it up to one of the input circuits. I have a faster input circuit over here. So the first one, the old version, which is horribly stupid. This whole thing with the books was completely pointless. It's because I didn't know that you could, for some reason I never had the epiphany that you can just simply use a line of repeaters to get a comparator strength. Anyways, what I was doing is it would load one digit in and then slowly one by one move them over from this end. So it would go that one to there, and then that one to there, and then that one to there, and then the input to that first line. Horribly slow. Got a new system over here, which is similar to what I'm using for the stepper on the division circuit, where it jumps the whole line at once, which obviously is so much better. So now I just have to basically connect this to that, but that's just for show. I might as well put the whole calculator together at this point now that I have division working. I just wanted to record this quick video. It's the middle of the night. I'm about to go to bed. It is 8 a.m. and I have work at 3 p.m. But there you go. 5.57692 is the result of 145 divided by 26. I'll do like a little bit more flying around. This thing is massive. It is so big. I know that this can be done much smaller and much faster, especially using binary. Once again, I want to explain that my project is to use comparators to do math. I could use binary, and there's lots of fancy math tricks that you can do when you're using binary circuits, but this is going to be slow because it's using comparators, and I'm not that great at Redstone. This looks complex, but some people will tell you that it's really basic. It's just a bunch of subtractors in line with each other. You get the remainder, you do one digit at a time. It's slow, it's clunky, but it works, and I am personally proud of building it. Alright, video's 10 minutes long, so I'm gonna cut it off here.